So we're going to talk how to use the quadratic formula. And the idea with this is that we're going to be focusing on quadratic equations that really can't factor. So the types of answers that we're going to see, for the most part, are going to be irrational numbers. Now, this question, the first one says to complete the square. We're just going to go right into the quadratic formula for this. So again, the idea with this formula is you have three values, A, B, and C, and those numbers go into the formula to help you find those roots. So first thing I'm going to do with each of these, and I want you to do that as well on the assignment, is write down the values for A, B, and C. That way when you're substituting later, you'll have them there to look at. So for A, there's no number in front, so there will be a 1. B is -6, and then C is 1 as well. So I'm going to go ahead and write the formula out. And then I'm going to take my next step, and I'm going to go ahead and take all the numbers and plug them in for A, B, and C. So I'll have -6 in for B, and then I'll have -6 squared minus 4, 1, and 1. And that's going to be all over 2 times 1. Now, moving on from there, I'm going to simplify 3 parts to this formula. I'm going to simplify the part before the plus minus, the part under the radical, and the denominator. So I'm going to end up with, for this, 6 plus or minus. I will take my calculator and I'll plug in the part underneath the radical. So if I clear that out, and I got, in this case, so I got -6 squared minus 4 times 1 times 1. Okay. So I'm getting 32 for that. So 6 or plus or minus radical 32 over 2. Now, next thing we want to do is see if we can simplify that radical. So I'm going to go ahead. I'm going to simplify this radical 32. I'm going to write it off to the side. And the goal of simplifying a radical is to find whole numbers that can be factored out. So you want to think of the perfect squares, the radicals that give you perfect squares. We talked a little bit about those when we did exponents. And here's a list of a few of those. These are the ones you want to start with. I'm going to run out of space here, but there's also 81 and 100. And usually you want to start the highest one and work your way down. But 32 can be factored into 16 times radical 2. And the radical 16 equals 4. So when I rewrite this, I have 6 plus or minus 4 radical 2 over 2. And now my last step would be to see if I can divide or cancel any of the whole numbers. And I can divide each of them by 2. So I'd have 3 plus or minus 2 radical 2. And then the 2 in the denominator would cancel out. Now this represents 2 different answers. There's 2 answers to this question. There's 3 plus radical 2, or 3 plus 2 radical 2, excuse me. That's one of the answers. And the other answer is 3 minus 2 radical 2. And if you put those in the calculator, you're going to see their decimals. And if I was to go ahead and graph this, x squared minus 6x plus 1, minus 6x plus 1, you can see that I won't find any zeros on the table. And if I go to the graph, so there's 2 places where it crosses. But if I go and try to find those, I have an answer that's between 0 and 1 when it jumps over the x-axis. I also have another answer between 5 and 6. So if I was to find a decimal form at each of those, one of them would be between 0 and 1, and the other one between 5 and 6. So that's kind of what we're looking at for the quadratic formula. It can be used for any quadratic to find the zeros, but it's more important when you have answers that aren't going to be whole numbers. So let's go ahead and take a look at one more together. So I'm going to go ahead and take a look at 4. And the reason I picked 4 to do next is because there are two ways to do this. This one is factorable, but it's also can be done with the quadratic formula. So, talking about the factors for this, so I'm going to try 2x and x. And then it looks like I'm going to try a positive 6 and a negative 1. So I'm going to check for my middle term, negative 1 and positive 12. So that'll give me 11. So that means I can set these equal to 0. So I have subtract 6 on each side. I have x equals negative 6. And if I add 1 and then divide by 2, I get x is 1/2. So I have two zeros, two solutions, 1/2 and negative 6. So I'm going to do this one with the quadratic formula now to show that I'm still going to get those same answers. So again, I'm going to write down my a, b, and z values. A is 2, b is 11, c is negative 6. I'm going to go ahead and type those in the formula. So we got negative 11 plus or minus square root of 11 squared minus 4 times 2 times negative 6. And all that's going to be over 2 times 2. So that's what my x values are going to equal. Now I'm going to go ahead and simplify those three parts like I did in the last question. So we got negative 11 plus or minus. I'm going to pull up my calculator again. And then I got 11 squared minus 4 parentheses 2 parentheses and negative 6. So we get the square root of 169. And that's going to be all over 4. Now, that square root of 169 actually ends up being 13. So, I have all whole numbers. I can't reduce that any farther, but I have two answers. I have negative 11 plus 13 divided by 4. And I also have negative 11 minus 13 divided by 4. Now I can type those into the calculator. So if I do alpha y equals for my fraction, then I got negative 11 plus 13 on the top. Move to the bottom, put a 4 in. I get 1/2. So 1/2 is one of my solutions. Then I got negative 11 minus 13. Oops. Alpha y equals, there we go, negative 11 minus 13 divided by 4. I get my other answer, which is negative 6. So you'll see the answers that I have for the first one and the second one, the different methods are the same. So if you do get stuck trying to factor, well, you can always use the quadratic formula that we didn't go over in Unit 6, but we're going over now. So as you're looking at some of the examples on the next page, try to focus on a few things. First off, writing down your numbers, like I did with my A, B, and C values, and then simplifying those three parts. And then if you get stuck with the radicals, remember, think about the radicals that give you whole numbers out, because you're trying to use those as factors. So I'm making a list of those on the bottom of the page for you to look at. And pretty much if you look at these ones, these could help you with probably about 90% of the problems.